All right, so did you guys get the oxidation states? What did you get for your oxidation states? In other words, am I right? Is this electron poor? No, I'm wrong. It's not electron poor. What is it? It's electron rich. How did you come up with electron rich? Well, how do you come up with electron bridge? Well, first off, we got to be able to assign the rules for oxidation states. So let's take a look at that. The rules are just not so difficult. Which one goes first, hydrogen or nitrogen? Hydrogen. What's the charge on hydrogen? How many do we have? 4. So that gives us a total charge of. This whole thing has to have a plus charge. There's got to be an imbalance of electrons so that we end up with a +1 charge. To get that imbalance, then we need to add how many negative charges to this? It's got to be -3. -3 plus a +4 gives us a +1, which is the imbalance of charge. And so that means this nitrogen must be a -3. That means that nitrogen is electron rich or electron poor or just happy as is. These are things you memorize. You memorize that oxygen at -2 is happy as is. You memorize that because of water. What about ammonia? Is ammonia as stable as water? Or more reactive? Does water burn? No. Does ammonia burn? Yes. Ammonia burns. Like you don't want to smell, but it burns and generates toxic gases. So you don't want to burn ammonia. It'll generate really noxious gases. But these are little things that you register in your mind so that you have these little reference points. We need little reference points to understand this. When we see this, it's like, this is a new table. This new table is like moving to a new city, and you need some kind of reference points. Did I mention this before? When I moved to Torrance area here, I was trying to go down to the beach, so I was driving on Carson, but I was driving the wrong way. I had no idea which direction I was going. I ended up driving 30 minutes the wrong way. But anyway, it's the same thing. You need some kind of reference points for a table like this. Otherwise, it's just a new city. And so here, we figure this out, like how water behaves and this type of stuff from charts like this and from oxidation numbers. And so when we see nitrogen in -3, well, ammonium and ammonia, ammonia is the same thing, NH3. What's the oxidation state of nitrogen and ammonia? -3. That's it. And so then I make an association. Ammonia. You don't throw those things into fire because those are electron-rich species. They can react. And so we make little associations like that, like CO2. CO2 is +4. Oxygen's -2. And so we might think, hey, CO2 is really electron poor, right? But is CO2 really electron poor like oxygen? Oxygen's a powerful oxidizer. Oxygen's electron poor. CO2 must be electron poor too, but then you think, what do they use CO2 for? They use CO2 in fire extinguishers. Why would they use CO2 in fire extinguishers if it's electron poor? Wouldn't that be like fanning the flames? You know, you fan the flames, you get more oxidizer in there, you get more oxygen. So if we are spraying CO2 on a fire, isn't that like fanning the flames because giving it more oxidizer? This is electron poor, oxygen is electron poor. It turns out no, because CO2, even though, yeah, you would think it's an oxidizer, you would think it's electron poor, is fairly stable as is, you know? So carbon plus 4 must be okay. If you look at the geological world, you know, most of the rocks out there that contain carbon are carbonates. You know, if you look at carbonates, what's the oxidation state of carbon in carbonate? What is the oxidation state of carbon in carbonate? Well, how many oxygens do I have? 3. What's the charge on each oxygen? Total negative charge is -6. This has got to equal -2. So there's got to be an imbalanced charge here, which creates an ion. So it's going to be +4. That means carbon is +4. Are carbonates strong oxidizers? No. So it must be happy as is. So you make these little reference points. You know, it's like little guide points that you can use in the future. So, so this is okay. +4 here, but a +4 on a different atom might not be okay. A -3 on nitrogen is kind of reactive, whereas you know, a -2 on oxygen is not. And so you make little points like this. A -2 on carbon, like in ethanol, is reactive, and so we look at it element by element basically and see, you know, how they react, and then we come up with this formulation just to get an idea of the reactivity of these species. So I would think this is not electron poor. This is, I would think, on the electron rich side. Now, how electron rich is that? Well, let me tell you, we need some kind of well, actually, we don't need anything. I can just show you how electron rich this is. This is quite a bit more dangerous than something like this. Sodium nitrate, we call this an oxidizer. Ammonium nitrate, we call this a dangerous chemical. Well, sodium nitrate is also a dangerous chemical, potentially. If you take this oxidizer and you mix it with reducers, especially powerful reducers, you can get a reaction. But ammonium nitrate, on the other hand, is just plain dangerous. Why? Ammonium nitrate is a very dangerous chemical because nitrate is a oxidizer. It's electron poor. Even though it doesn't seem electron poor, it's electron poor. Did I already do a nitrate? Did we do nitrate? I guess not. Nitrate, is that really electron poor? Yes, it is. Oxygen's happy. Nitrogen must be, well, nitrogen must be what charge? +5. Is it happy? No, not really. Nitrogen at +5, we call it electron poor. And so here we have our oxidizer. The oxidizer is electron poor. Over here, ammonium, unlike sodium is not a very good redox. And if it does do redox, it's an oxidizer. So oxidizer. This oxidizer is way better than this oxidizer. However, ammonium is not an oxidizer. Ammonium is a reducer. So what we have is we have a reducer and an oxidizer in the same compound. When we have an oxidizer and a reducer in the same compound, we could have self-reaction. And so, do you know Texas City in Texas? Texas City is very famous. Texas City is very famous because that's where the worst industrial accident in the U.S. happened. So let's take a look at Texas City. Near Houston or Galveston, I'm not saying Texas. Look at the power plant.
You can't spend much time in Texas City with all the big ships that come and go, the oil and chemical refineries, the pipelines and storage tanks brimming with flammable products. You can't spend much time here without thinking the unthinkable. Could it happen again? Could Texas City be another boom town in the worst possible way? 50 years ago, Texas City burned its way into the nation's conscience. The worst industrial accident in American history made Texas City synonymous with disaster. The day it happened, Will Lane was very near the epicenter.
Feels real strange. I'm real glad to be alive.
Lane was a young chemist at the Monsanto chemical plant. He remembers seeing the bright orange smoke from a burning ship. Firefighters were busy pouring water on the French freighter Grand Camp at the city docks across from the Monsanto plant.
You could look at it, it was real pretty to watch. And there were townspeople by the hundreds that lined the part of our parking lot that was nearest to the ship. They came down to watch a fire.
Texas City had a new fire truck, and this was its first day out. 27 firemen were on the docks trying to put out the fire. The burning ship was so hot, the water around it was boiling. But as a chemist, there was something about that orange-colored smoke that worried Will Lane.
We get to see bits and pieces of paper bagging going up in the air and away. And our boss thought, and I thought too, that we were witnessing a nitrate fire. But someone had said, it's a drain ship. The drain is on fire.
So believing it was only a matter of time before the fire was out, Will Lane went back to work at the Monsanto lab. But the fire was growing hotter, and the orange smoke was attracting an even larger crowd along the docks.
It was a very, very strong sulfur in the air, sulfur fumes.
Herb Metzger watched the fire while talking to a group of high school kids.
This smoke was just a beautiful orange.
Mary Hunter, a Monsanto secretary, was watching from her office window. And across town, Mrs. Knappenberger, a housewife with a home camera, came here to the Texas City dike to get a closer look at the burning ship. She didn't know it then, but she was about to record America's greatest man-made disaster. The ship had been loaded not with grain, but with ammonium nitrate fertilizer, the same ingredient that would be used years later in the Oklahoma City bombing. The Texas City blast was so strong it registered as an earthquake in Denver, 900 miles away. It created a tidal wave that washed a barge into a parking lot. 2 airplanes circling the ship were blasted from the sky. Flying debris punctured chemical storage tanks, creating an even larger inferno.
We have another truck up here off of the road. It had about 10 or 15 men, and they were all crushed.
The explosion killed at least 581 people, including school children who had come to watch the fire. But the danger was far from over. Tomorrow, we'll hear the stories of survival and courage from the people who were there 50 years ago. Charles Hadlock, 11 News, Texas City. This is Charles Hadlock. Texas City has tried to outlive its past, but it's hard. There are so many reminders. An anchor here, a propeller there, and sad, sometimes painful memories all around. Even today, 50 years later, the tragedy is not forgotten. 6th Street, the once busy main street of Texas City, has been renamed the Street of Memories. For it was along this street that so many screamed and ran for their lives. The explosion of the French freighter Grand Camp left an entire town dazed and confused.
And I ran as fast and as hard as I could.
There are many stories of survival. Dr. Will Lane was in the Monsanto lab. He had been watching with suspicion the bright orange smoke of the burning ship docked next to the plant when it suddenly exploded.
And the lights just went out. I could not see more than 2 or 3 feet. And I thought, my God, it was a nitrate explosion. I'll probably lie right here and be burned to death.
He got up, looked over his shoulder at the burning tanks of benzene, and ran for his life.
Passed a car in which 2 people had been decapitated. Then I passed one of the 2 little planes that had been flying around overhead, came down along the path that I took up into town.
I'm sure all that glass came into us. And I'm a must have gone like this, and so my arm was injured all in here.
Mary Hunter was also in the Monsanto plant. To this day, she still has shards of glass in her body.
I had it cut out of me, but luckily it had lead in it, and therefore when they x-rayed it, they could find the glass.
Before the explosion, hundreds of people were on the docks, including Herb Metzger.
I had turned to walk away. I had my back to the explosion, but the force hit me in the back, and it sort of just, I don't know, I would say it picked me up, but it moved me forward 20 or 30 feet.
Suddenly, pieces of the ship were falling all around him. He crawled under a car.
A couple of pieces hit the car. I could feel it, and it jarred, but nothing hit me.
Here comes another explosion. But pieces of metal did hit the High Flyer, a second ship loaded with ammonium nitrate. Efforts to tow the burning ship out to sea failed, and 14 hours later, it exploded. The fires burned for days. Nearly 600 people died, and 5,000 were left injured or homeless. Those who survived helped each other.
We had to drive some folks out that had telephone poles, in fact, I guess, or some kind of big poles going across them. They obviously were crushed, It was not a nice sight, but kind of steeled myself to it for a while.
Even after the dead were buried, many survivors never talked about it again. But over the half-century since the explosion, they rebuilt their lives and their city. That must have been a hard thing to do, with so many memories around. Charles Hadlock, 11 News, Texas City.
Okay, how did that happen? What year happened was 1940 something. Let me check. I forgot the year. There's actually a number. There's actually a number of explosions that happened. 1947. And then there was another explosion, a big one, in Texas City.
That was 2 years after the war ended.
April 16, 1947.
April 16.
Okay, thank you.
You have named 2 strong bases. Last class you said that amide was a stronger base, and then today you said that the methite is a stronger base.
Yeah, amide is the strongest base on that chart over there on the right.
So on this chart.
On that chart, methite is the strongest
Oh, okay.
chart. So that's why it depends on which chart you're looking at. We want to know the strongest. So that one's a little, has different species on. Methite is very exotic, so methite's not that common. So I don't know why they put it on our chart. They put it on our chart for. But anyway, amide is very powerful, and so it's up there. So you should know the name